just cover this. Fine. So today's topic is, are you able to see my screen?
Yes.
That PDF I really have, I'll give some another clue and try to arrange that PDF if possible. I didn't send that, huh? Lecture 9 PDF. Okay, let's see. So, copy it out. That is the means from this area, just we are going to discuss line integral, double integral, and try to understand how they are correlated with Green's theorem, Stokes theorems, and Cos Divergence theorems, and all. Okay, so let's go ahead for this all. Besides, as these all the part of the vector calculus, here that is. Okay. So what the series were going on for vector calculus, we have already discussed line surface volume integrals, Green's theorems, Gauss divergence, and Stokes theorem. These all applications we will see in this section. And but before this, let me take a quick revision. Acha, I have given a lot of theorems also. Na? You just please take a quick review of all those theorems of that one curls, nabla, operators, and these all gradients and others. Okay, that will be helpful in while when we make the proofs of Green's theorem, Stokes, and Gauss divergence. So let's me take a quick review of this line integral, and that is surface integral, and that what we call volume integral, and how these integrations are uh, correlated. As the topic is going, what we discussed here. Let's see. That is the vector integration. That is here we say vector integration. That is topic is vector integration. Vector integration. Okay. So actually in this vector integration theorems, there are vector integration theorems. Actually, we have to go for vector integration theorem. In vector integration theorem, that is concept. Okay. So if you see over here, that is in vector integration theorem, and some main theorems here. There are three types of theorems. One is there is that what we say second, that we call three theorems are important. Although theorems are many, and gradient theorems and others also we will go by. To just sake of convenience, we will discuss. So in vector integration theorem, first we have to go for Gauss divergence theorem, right? So that is called Cos Divergence Theorem. Cos Divergence Theorem. Clear? One of them is Cos Divergence Theorem. Yes, Cos Divergence Theorem. And here that is called Cos Divergence Theorem. Okay. Then after we will go for another theorem that we say it is called Green's theorem, right? Green's theorem. Green's theorem. And another way called as Stokes theorem. So we say here Stokes theorem. This is Green's theorem. Okay. And then after we have to go for later on Stokes theorem and detail about these theorems. We will prove these all theorems, and besides we will do some problems also, right? Stokes theorem. So this is Stokes theorem. Okay. So 3 theorems we have to go ahead. One by one we will discuss in detail the Cos theorem, and that is also called here that is Cos Divergence Theorem, and here that is Green's theorem and Stokes theorem. What Gauss theorem do over here? Let's see. So for this Gauss theorem, this one is for Gauss theorem, it gives the relation between double integral and triple integral, right? What Gauss theorem do for us, that you say that here we can see that Gauss theorem provides the relation between this one and this, okay? That what Gauss theorem can do for us, it gives the relation, it gives the relation right between double integral and triple integral, that is double integral and triple integral. Means the problem which we hold for triple integral, that it can be converted in double integral, and means you can say that is the relation between double integral and triple integral, right? That is the relation between double integral and triple integral. It gives the relation between double integral and triple integral. Okay. It gives the relation, you can say, between say double integral or triple integral. Double integral and triple integral correct? So this is the relation between this Gauss Divergence Theorem will do. Later on we'll discuss in detail. Okay. And what about this one? This is the double integral and triple integral relation. And here what these all do, this one Green's theorem. What Green's theorem do for here? It gives the relation between, you can say here that Green's theorem. What Green's theorem do? It gives the relation between, not double integral, it gives the relation between, what Green's theorem do? Can you tell? Single single integral, and that is double integral, double integral, double integral, right? That it means here you can see what this. Yes. So Green's theorem can do here for us, that is single integral to like this. Okay. And now for Stokes theorem, what is for one thing I want to tell about here, that is the I, that is you can say, that is the single integral into that we say double integral. So by this mean you can come into memory. What this one do Stokes theorem? Stokes theorem converted also, it is the same like Green's theorem. It gives the relation between single integral and double integral, right? You can see over here, right? So let me do this. So you can say over here, it also provides single integral and double integral. This one, Stokes theorem. Okay. So Stokes theorem do also for this, that is single integral and double integral, single integral and double integral, between single integral and double integral, single integral and double integral. Yes, that is the Stokes theorem. This is the Stokes theorem, and Stokes theorem, what we do, that is still that we say here also, I, that is single integral into, that is you say double integral, right? That is the double integral. That is the overall concept of this. So the reason is that the thing which is we can do for single integral, then why we convert it in double integral. The thing which we can do with the double integral, why we go for triple integral. That is the issue. So just for sake of convenience, the problem which is too difficult for this one triple integration and double integration like this. So we can go for converting this double integration in triple integration, and like this here in this one single, double to single and triple to double integration. So why these theorems are used? That is the important. While evaluating the integration of single, double, triple problems, we can means go through this one. Single integration is too hard. Single integration is too hard, but if we can change the same problem into double integration and the integration problems become simple, and in such cases we can use that like this, you say that is Green theorem, and if the surface is in xy plane, let me write here, or what is the difference between this one Green's theorem and Stokes theorem here? In Green theorem, actually when we convert the problem of integration problem becomes simple, in such cases we use Green theorem. If the given surface is in xy plane, you can just use the Stokes theorem also, although Stokes theorem can go for any plane, right? So if we want to change the double integration problem into triple integration, then we can use this Cos divergence theorems, right? So Green's theorem is used, let me write here, that is, you say, that is the note point, you can say, note point, right? So Green's theorem So means that is the node point here. Node is here. Let's go. Number one, right? What is Green's theorem? You say Green's theorem. It is very clear that single converted in double. So that is Green's theorem is used used if you say if the given surface if the given surface if the given surface is in xy plane is in xy plane, right? Only and here number two, that is although Stokes theorem. Later on, we'll discuss detail about Green's theorem and Stokes theorem both. But what we are planning to just make the foundation of Green and Stokes theorem. So Stokes theorem is used used for any surface. You say, used for any surface, right? Is used for any surface. Bracket. You can say means any surface means any plane. So you can go for either xy plane. So wherever Green's theorem is applicable, Stokes also. So xy plane, yz plane, and zx planes, right? And any of zx plane or any else plane. So any plane, right? So what this Green theorem and Stokes theorem signifies? जस्ट अच्छा ये क्या किया जाए, ये ग्रीन थ्योरम और स्टोक्स थ्योरम बस केवल डेफिनेशन लिख करके आगे बढ़े कि आपको सिंगल डबल ट्रिपल डिटेल बताएं आप? मैं फिर से आपसे पूछ रहा हूँ, आप क्या करना चाहेंगे? डिटेल समझना चाहेंगे? मतलब इसमें थोड़ा टाइम लगेगा, लेकिन बोलिए तो मैं डिटेल पढ़ाऊँ.
Yes, sir. Could you go into detail?
Okay. So first of all, we'll focus this one. Single, double, triple integration, do some problem, and then we'll come back and we'll use
Yes.
this Green theorem and Stokes theorem and Cos Divergence, and in which different fields and how we apply this all, we'll go for detail, right? So let's go
Yes.
ahead. Fine. Okay. So I'm not going to just introducing Green and Stokes right now. So first of all, we will concentrate on this one, how we are using and why we are using Green's and Gauss divergence theorem and Stokes theorem. And later on, we'll better just I will explain this all. So I will concentrate on first, that is the concept of line and surface integral. So in the line integral, you see that what we have to go for, although I have given the idea also of line integral and surface and so first we have to concentrate on line and surface integration, right? So in the line integration, that is the scalar field, vector field, others also. So one by one we'll go ahead in detail. So you see, give heading line integral of scalar field first, and we'll do some problems also, numericals also on these questions. So let's go ahead and then we will connect. It's okay. So you have to have a patience, more and more patience to understand this all and how they are related and how we use different in different branch in physics. I will give the idea. It's okay. So let's go ahead. So that is the first. Let me give the heading. Integral of line. First we have to, we will study line integral of a scalar field. Of a scalar field, right? Scalar field. In detail we will discuss today. Okay, fine. So let me. This is the heading. Line integral of scalar field. So today's topic is line integral, the scalar field integral. Scalar. Okay, fine. So, and then we will go for, after this introducing line integral of a scalar field, we will do some problems, 1 2 problem over here. Then we will go for arc length in this same, it's okay. And we will go for arc length, and we'll do some problem on this arc length. And then we'll go for line integral of vector field instead of a scalar field. We'll go for vector field and discuss how these are, and then we do some problem about this 1 2 problem, and then we go for work energy theorem, and then we will go for more numericals on line integral to just make a practice. Then we will understand what the line integral is, and then later on we'll go for surface integral. So first, let me discuss line integral in detail, right? So what is line integral? Let's see. Line integral of a scalar field, right? Although it's pretty easy, but line integration is uh, it is a simple integral and line integral. That is the different thing here, right? So this is along with some curve, that is the line integral, directional curve. Also, you can say that is contour. So let's say any function f is equal to f of r. That is, you say a scalar any field. Okay. So let me say this is a scalar field. You can say here, let this function be any scalar field, means f of r. You say here, let's see, say fr be the any function. Let it be f of r. Let's say a scalar field, a scalar. Okay. Scalar field. Scalar field. Let any scalar field f equal to f of r. Okay, f equal to f of r, and over a curve, over a curve, any curve you can consider. Okay. So curve you can say C. Uh, so if you divide this curve in some small segment, let's say like this way, this is, and here some small segment, that is, you say here this length will be ds, and if you consider this as length, you recall as here, that is, say let this be x-axis, and this what we call y-axis, and we make this as any vector. That means this is along with x-axis. You see, let's say this is x-axis, this is what we call y-axis. So if you consider this ds length, this part, so what we say over here on xy plane, if this is in xy plane, you see this one is in xy plane, right? Let's say this be any xy plane, right? So you can consider here as xy plane, and then this is an xy plane we have to consider, and here this is, okay, fine, let it. And so if you see in this ds means this length is, so is ds that what we say here, how to find this ds, how to find this ds in xy plane, can you tell? Ds is equal to, what do you write? Actually this ds, if you consider this ds as, this part of the ds is here, this part, right? This part ds, so this part ds is there, and when we consider this small infinitesimal length, this is dx let, and this be dy. So nearly that is ds dx dy. You can say this is the, according to Pythagoras theorem, you can say dx whole square and plus dy whole square, and that is ds square. So better just write ds is equal to under root of dx square, isn't it? Can you write like that? So better just write ds over here like this. When you take a dx common, you can take a dx common over here. There's a y is a function of x. Let's say this be any function. So if it is directed along y-axis, as in mean of any f function, so that we say under root of, we can recall as dy by dx whole square, right? And you can take this dx common and outside from this integral. Sorry, this is square root, right? So can we write like this way? So that is nothing. It is under root of 1 plus that what we say. This is the differentiation of y dash of x, divided by dx, and that is whole square. So that what we have to say whole square, and that is dx, clear, and that is dx, and that is called ds. So if we go around for the integral of as in this we have to find the line integral along with this curve, what the direction of the curve is here along the counterclockwise. You say f of r dr, f of r dr, not but dr, you can say over here ds as let me make it ds, that is f of r, that is as we have considered fr, so we have to go for this one ds. R is any position of that is any point, and along with this function. So then what we have here, integral over c, this is the line integral, and that we say f of x comma y, right, and that is ds, that what we call integral of that we say x naught to means final position, initial position to some final position. In terms of f we are notifying, so f of that is say x here, and for y that what we call that is y of x, whatever the variable depending on x of this dependent variable y, and under root of that is for ds, what we replace this all, that is 1 plus what we call y dash of x whole square, right? And here that is you say dx. Can we write like this? So finally, this is the formula for line integral as the function of x. Sometimes here in the question they can give this x and y as a parametric term, right? One more situation arises over here. So when this is a one-dimensional function, then that is no issue. Y of x, you can go like this way, right? But when it is, if the curve means parameter, you can say parameterized by t, if the curve, let me write here, if uh, if the curve, if the curve, you say parameterized, means parameter form, parameterized, you can say, you can use this word parameterized by t, any real parameter, let's say t. So how x is equal to any other function x of t, and y as a function of y of t, some any parameter relations is given between x and y. So nothing to do over here, ds is equal to that what we have discussed here, that is dx square plus dy square, and you just separately differentiate with respect to t for x and y as x dash t, y dash t. So ds you can write over here very easily, that is nothing, that is x means that is dash here, better just write this is dot also fashion to write over your differentiation. So can I write here x dot t, that is whole square, okay, and here y dot t, y dot means derivative, so that is whole square, and that is one thing, that is dt is also there. Are you getting this one? What dot this reinforce? Dot is differential, first derivative, right? So the line integral then becomes, so in this situation, what does line integral then becomes? The line integral, the line integral, integral then becomes, then becomes line integral then becomes integral over c, and here f of x comma y ds was there, ds. So just substitute these values, right? So according to x naught, that is the term parameter t naught, and for this xf corresponding means tf, because now we have to consider the parameter in terms of real parameter t. So tf, that we say, and now substitute these values of x and y over here. So f of, you say, x of t and y of t for x and y, you just submit over here, and under root, that is for dx, you have to write this one x dot t whole square, and y dot t plus y dot t whole square. Okay, here you have to write plus, and that is dt, and that will be the formula. Is it all right? Are you ready?
Yes, sir.
Fine. So that's why you can go ahead and may I go for Arclip also, or just let's discuss some problem. Can you take numerical on this? So
Yes.
you, so you can do the numerical also. Short numerical. That is just means from just like from that same pattern we have to if the parameter form given, then we can come in the previous form also, like this we can also derive. That's okay. Later on itself, let me go for this one, arc length, right? So let me complete this topic at least line integral, and then we go for yes. So let's say sometimes here in a problem they ask for arc length. So let's go ahead for arc length also. Arc length. Fine. Let's see. Arc length. So you have to go for arc length. No, limit point here. The arc length of let's say any arc length means arc is the segment of any curve that is called arc. Like if you consider this circle and this part is the arc here, so this P is the part, P is the arc length, of entire curve. If you consider any ellipse, right? So in ellipse, this part, that is the arc part, like this. So that is called arc length, and arc length is also a very, very important thing here. So here to discuss this, we go for ellipse, right? Ellipse, do you know what is the equation of ellipse? What is the equation of ellipse? Do you know?
Yes, sir.
X square by a square plus y square by b square is equal to 1. That is the ellipse, right? So let me go ahead. Arc length. Let the arc length P of a curve is given by let's say P is equal to integral over, that is circle, it's along curve, that is ds, right? Let's we take some question over here. Let's see, P of a curve is given by this part. is P equal to integral of C, that is ds, right? Let me say, for consider any simple curve. Uh, let's say, for example, that we consider the circumference of the ellipse, right? The given equation of the ellipse with centered origin, let's say x square by a square, and this is the equation of ellipse, ellipse, ellipse you consider, and y square by b square is equal to 1. You say you should know the structure of the ellipse, that is here. This is the ellipse, okay? And let's say this word is the ellipse, clear? And here let us say x square by a square plus y square by b square is equal to 1. This is the ellipse, okay? This is the equation of ellipse, okay? What is the a and b? This length is semi length is a here, and this is also called semi major axis. That is semi minor axis, that is small b. Okay, so let's say this length is, let me note up here. So you can see over here, this length is, let's say, x axis, and this what we call, you can consider this as y axis, and y axis over here. And this length, this length is here, that is this length is here. You see, this length is that is a, and this length is that is here, that's b length, means this length, right? So that is here, it is called b length, and here that is called small a length. From here to here, this part, this length is known as small a, right? So here you can see this part. Let's say this length is a, and let's say this length is, you can recall as b. This length is, let's say, b. So when you say over here that this be x and y axis, and here that some eccentricity is there, so we have we have already assumed that a is greater than, you can say equal to also, greater or equal to b, means a is always greater than b. When they both of them are equal, then it will become circle, right? So in this situation, eccentricity of ellipses, eccentricity of ellipses defined as ellipse that we call under root, means 1 minus b by a whole square. Okay, means you can recall as b square is equal to a square into 1 minus c square. That is the equation of ellipse, and here that is from here, when you solve this value e, you will get this under 1 minus b square by a square. As here there is the parametric form, when you consider this any point on the parametric equation of this ellipse, let's join this p here, then this point is, let's say, p is here, that what we call a cos theta and b sin theta. Achha, p is the parametric point, a cos theta, and that we call b sin theta. This is the parametric form. Achha, one thing I want to tell about this ellipse here, that this is not theta, you should know well. This is some another angle, and actually this theta is also called eccentric angle. This comes from auxiliary circle, but I'm not going to go in a very detailed depth here. If you are interested, then I can tell about this here, where the theta here, if you extend this PN line, that it means you say here this line is as PN line over here, means let's say this point is PN here, this point PN here. When you extend this line here, then it intersects at some circle, the circle that will be having a diameter of this major axis. This is called major axis, 2a length, right? So from there you will get this theta, right? That will be a cos theta, and this theta will be the that is called eccentric angle, and the circle which having the diameter of this, the length of this major axis, that circle is also called auxiliary circle of ellipse, right? So I'm not going to in detail about this. I want to describe the length of this ellipse here. Just I have to write this as a question of parametric form, that we say, let's say x of theta. Let's say this is x of theta. Theta be the parameter, so we can write down a cos theta. So that's why I am explaining about theta. But mind this point, this is not a theta. Usually students have a misconception that this will be the theta. No, this is not a theta. Theta is somewhere else. If you are interested, I can draw this diagram properly, and I can show you where the theta exists and how this point a cos theta b sin theta is also there, right? So hope so you all are getting. Y theta is equal to, that is, let's say that is b sin theta, right? So let's say this is, and how this comes on substituting this value of x and y in this equation of the ellipse. You can see over here. Now look at the point here, where theta goes, theta belongs to, that is 0 to 2 pi, 0 to 2 pi, right? So from 0 to 2 pi interval, right? So the infinitesimal arc length is, the infinitesimal arc length, infinitesimal, infinitesimal arc length. Actually, we have to find arc length. Arc length. What is the infinitesimal arc length? So the infinitesimal arc length can be evaluated as ds is equal to, that is under root, that what we call, previous we have discussed, dx square plus dy square, by this as blue color. So substituting this value here, what we say in the parametric coordinate, you can see this is also a type of numerical of that previous results. So if you say here, that is x dash of theta, right, whole square, and plus y dash of theta whole square, right, and that is d theta, and that is ds. Are you getting this one?
Yes, sir.
So what is the differential of x dash theta, as we have chosen over x theta equal to a cos theta and y theta? Achha, how this comes? You see the parameter is a general coordinate, x equal to a sin theta and y equal to b sin theta. This satisfies this equation. This satisfies this equation also. You just submit these values over here in the left hand side, x square by a square plus y square b square. X square you just put over here, x square a square cos square theta, a square cancel cos square theta, and here b square sin square b square cancel sin square cos square theta plus sin square theta, that will become 1, which satisfies the equation of ellipse. This point travels throughout this one on the periphery of the ellipse, right? So we have to consider the arc here. So x dash theta is differential of that is a cos theta. We have to differentiate now. So a cos theta differential is a cos theta, that it will be minus a sin theta. So finally minus a sin theta. So finally that is a sin square theta, right? And here what about this one? That is also b square for differential of sin theta, that is cos theta. So b square cos square theta, right? And that is called d theta. Is it okay? And hence we say ds is equal to what you can take out common. You can take out over a common over here. And what I'm doing here, that I'm converting this sin square theta in terms of cos square theta. So sin square theta you can write 1 minus cos square theta, and after multiplying this a square, we get here a, you can take out a common, right? So once you take out a common from throughout here, what you will get here? 1 minus, because 1 here for sin square theta, you write 1 minus cos square theta, and then multiply with a square, then take out common a square 1 minus, and then you can write this in bracket, and here we say 1 minus b by a. If you will not get, I will write one more step here properly, don't worry, by this as cos square theta. Are you getting this? Are you getting this or not? Look here, what I have done here, sin square theta, I have converted this in 1 minus cos square theta, right?
Yes.
1 minus cos square theta, and I had taken out throughout a square common. So from this, for 1 minus cos square theta, we got this one, and from these two terms, when we take out a common, then that is 1 minus, that will become cos square theta, na? And cos square theta here, that is common. Is this all right?
Yes.
Are you getting it? So what do you say here? I have written this. The reason behind this is because here we can make uh, terms in eccentricity as 1 minus b by a whole square. Directly we can write over here e. E is the eccentricity part. Is this all right? So here that is also called, we can say, that's why I have chosen this concept. So for this 1 minus and this what we say here, what we can recall, that is for 1 minus b square by a square. What do you say about 1 minus b square by a square?
E
Bigger
square.
square? Yeah, e square, that is. So 1 minus, what do we say? E square cos square theta, where e is eccentricity, and that is d theta. So you say here, actually we have to find the arc length. So what the arc length formula is? The arc length formula is p is equal to integral of cds. So along with this curve, you have to integrate integral of, that is, c ds. You see over here, and that is a into integral of, that is 0 to, that we say 2 pi, right? 2 pi into under root 1 minus. Why I am writing 2 pi? Are you getting? Entire curve means we have to find the entire length of this ellipse, right? So entire curve, and this is go from 0 to 2 pi. So up to 0 to 2 pi, we are considering this entire elliptical curve. So that is 1 minus e square, and here that is cos square theta, and that is called d theta. And what's so call about this as, that is 0 to 2 pi. Perfectly, if you say, see over here, this diagram, then this is symmetric in all the quadrants. You see, if I take this length here, this length, this part length, this part. Consider this part length, this part. If I give you this part length, then you make a 4 times, then can't you find this is same? This part and this part is same, this part is same, this part is same. So it means when we go for integral from 0 to pi by 2, means 90 degree, then we recall for this part. And when we go for 0 to 2 pi, then we recall this entire. So that is the new symmetry, we can say, that is 4 times of 0 to pi by 2. So that for 0 to 2 pi, what I am writing over here, we can say over here, this is a bracket, that is, you can say over here for 2 pi, you can say that is 4 times of 0 to pi by 2. That is the simple limit. In simple integration, we can write under root 1 minus e square cos square theta, cos square theta was there, cos square theta and d theta. Are you getting this one? 4 times of pi by 2.
Yes,
Are,
sir.
are, are you getting?
Yes.
Why 4 times of 0 to pi by 2? Although you can apply here integration, definite integration for properties also by the help of this cos square theta, that will be the even function property. 0 to 2a fx dx, twice of 0 to a fx dx. Are you getting? What is the property? Property is 0 to 2a fx dx is equal to twice of 0 to a fx dx. When it occurs, if f of 2a minus x, if f of 2a minus x equal to fx, right? And if f of 2a minus x equal to minus fx you find, then the result will be 0, isn't it? So that is the property also of definite integration. You can see over here. So this I have written over here just to recall this. I will left. This is the property. By this property also you can find this concept of integral. Okay, so we put this property and I will put over here just for reference point of view. This is the property. This property we have used here to just make this. You have to use this property twice on this. First, you have to apply on 0 to 2 pi, because cos 360 minus theta, that will be plus cos theta, and although that is a square, whole square, that you will get the same function f of 2a minus x equal to fx, and in this way you will take out 2 common, 2 times of a0 to pi, and then once again cos 180 minus theta, that will be minus cos theta, but that is the whole square. So once again, well, function will be same, and you can say 2, then 0 to pi by 2. Are you ready? This is 4a. So either you can apply this property, or directly you can check this one, the concept here. It's pretty easy, that if we are instead of integrating up to 0 to entire 2 pi limit, uh, entire length of this ellipse, so we have to consider only on the fourth part, and we make the 4 times, then we will get the same result. So we are interested to integrate 0 to pi by 2 only, and then we go for 4 times. When you make 4 times of 0 to pi by 2, then you will get the same result, and that's what I'm doing over here. That is the geometrical significance also here, you can see. So what we say, final integral is over 1/4 of the arc length of the ellipse, and it is called the complete elliptical integral of the second time, right? So this is also called in physics, you can say, final integral. Final integral, you can say, final integral is over 1/4. Is over 1/4, 1/4 of the arc length. Arc length. Arc length. Arc length of the ellipse. Ellipse. It is called the complete elliptical integral, and is called the complete elliptical integral. Complete elliptic integral of second kind of the second kind. It's solid. This is the integral. Okay. So we can take the problem over here. Are you interested to take the problem? So let me take the problem on arc length. Are you interested to take the problem, or let's go ahead?
We'll go ahead, sir.
You go ahead. Better. On circle, you can. I will send the problem, right? You solve further.
Yes.
Better just I will send the problems in the PDF format, and you solve. And if you won't get, then we will discuss it later on, right? So better just go for line integral of vector field now. Now let's go for line integral of vector field. Yeah. So line integral. Line integral of a vector field. Vector field. Okay. Line integral of vector fields. So for this year, you see that we have to consider this. Although this concept we had discussed in last lectures, so let me complete this. That u r either any function at u of r. Here we have to use vector field. So u r be a vector, be a vector, right? Vector field means this is along directed curve. C, directed curve, directed curve, right? So integral of C into u dot dr, u dot dr we have to say. U is also a vector quantity, right? So that is u dot vector quantity. That is, you see here. So means this we can also say integral of C, and here u dot, let's say t be any vector quantity, or means C, that is the unit vector here, and that is ds, and that is the result. Okay, so R be any function tt, means that we say here. So in general method to calculate the integral for vector field in parameterized uh, parameterize the curve, right? So using dr, for this you can say dr means this dr will be the dr vector, you can say. So dr vector we can say dr by dt, dr by dt, right? And here into dt vector, right? Like this way. So r be the function of time t, means not time, that is a parameter t, right? And the line integral will becomes, that is, that the line integral will become as integral of c, and here u be the any vector here. Let's say u be any vector, and u dot dr is also vector. So from this here, when we go ahead to integrate, so t naught to tf, where this is in parametric format, right? So that is u as a function of that was r, and here that is r as a function of any parameter t, that is u, and here this is dot product with dr by dt, although we can write over here, and that is the dt vector. Right? So for that dr vector, we have used this one, dt. Right. So sometimes the curve is simple enough that dr can be computed directly, and otherwise it's all okay. Let's we take example to understand this in detail. Here, let's say very easy example we will take here to understand this. So compute the integral. Compute. Let's we take question. You can say example also. Rather than doing question, you can say this is example. Compute the line integral. Compute the line integral. Integral, that is r vector is equal to xi vector plus yj vector, right? In xy plane, in xy plane, right? Uh, Along two curves from origin to along along two curves, right? From the origin to the point x comma y, to the point, let's say एक simple problem बना लेते हैं, let's say x comma y, okay, which is let's say that is 1 comma 1, तो ये ले लो point 1 comma 1 लिया, और फिर क्या हुआ? अच्छा, तो फर्स्ट कर्व क्या है? दो कर्व लेना है, तो द फर्स्ट कर्व you can say here C1 consists C1 consists of two line segments, ये भी है टू लाइन सेगमेंट्स. अब कैसे कैसे वो रिलेशंस बन सकते हैं? सेगमेंट्स, two line segments, the first from 0 0 to 1 0, right? And the second means 1 comma 0 to 1 comma 1, 1, 1, राइट, ये हो गया। और द सेकंड कर्व, ये तो फर्स्ट कर्व था, एंड द सेकंड कर्व इजी ले लेते हैं। सेकंड कर्व, सेकंड कर्व कैसा है? एंड द सेकंड कर्व, you see C2 is also a straight line from origin to 1, 1. C2 curve, C2 is a C2 is a straight line, is a straight line from the origin, from the origin to origin in 0, 0 to 1, 1. Right? Now, try to do this. Yeah. Simple question. Are you ready? Question. Compute the line integral xi plus yj. Line integral means that is directed at some curve and xy plane along the curves from origin to the point xi 1, 1. Origin से 1, 1 तक जाना है। अब दो तरह के कर्व्स हैं। The first curve C1, two line segments, छोटे छोटे दो segments हैं, from 0, 0 to 1, 0, and the second 1, 0 to 1, 1. Right? हमें 0, 0 से 1, 1 पहुंचना है। The second curve direct 0, 0 to 1, 1. So what the result will be? Let's go ahead. So first curve requires two separate integrations, right?
Yes, sir.
तो कहाँ कहाँ पे कर्व along x-axis, along x-axis में किस में, and the direction of j,
X-axis and
so dr के जगह आप देखो क्या यूज करोगे, the line integral is क्या लिखेंगे,
dx dx I capital.
फर्स्ट कर्व के लिए ऐसे लिखो, ऐसे ऐसे चेंज कर दो, yeah. So what do you compute here? You have to compute along the first curve, requires two separate integration, right? So that is integral of C1, मान लो फर्स्ट कर्व के लिए C1 लिख लिया, तो C1 इक्वल टू R डॉट डी आर, ये लेना होगा। सो अब R डॉट पहले क्या हो गया, पहले 0 to 1, 0 to 1, दैट इज अभी क्या लेना होगा हम लोग को, डी आर क्या अलॉन्ग एक्स एक्सेस जा रहे हैं ना पहले, तो डी आर के लिए क्या लिखेंगे, एक्स डी एक्स, vector
Yes.
x dx, and plus then after we are going from 0 to 1, then is y dy,
By
dy। अब इसका इंटीग्रेशन करो, ये इसका इंटीग्रेशन क्या हुआ, x square by 2, और ये y square by 2, 1 by 2, 1 by 2, 1 by 2 plus 1 by 2, that is 1। क्या आंसर आ गया, 1 आ गया। ये C1 कर्व के लिए हुआ। एंड फॉर द सेकंड कर्व, दिस इज फॉर फर्स्ट कर्व, लिखा कि नहीं, पहले ये लिख लिया, फॉर फर्स्ट कर्व, फॉर फर्स्ट कर्व, फॉर फर्स्ट कर्व, एंड फॉर सेकंड कर्व, फॉर सेकंड कर्व, सेकंड कर्व के लिए लेते हैं इंटीग्रल ऑफ C2 दैट वी से क्या होगा, फिर से R dr, राइट, R डॉट dr, तो दैट व्हाट वी गो फॉर 0 to 1। अभी सेकंड कर्व के लिए क्या हुआ, डायरेक्ट ओरिजिन से जो है ये 1, 1 पे आ गया, तो 0 to 1 व्हाट डू यू से, क्या लिखेंगे, डायरेक्ट ले 2t dt कैसे एक्सप्लेन करेंगे, आर यू गेटिंग हाउ आई एम राइटिंग दिस वन। और द सेकंड कर्व पैरामीटराइज कर दो, कैसे, आर टी इज इक्वल टू, इसको कर दो आर ऑफ टी इज इक्वल टू, आर टी को क्या लिख लोगे, टी अंडर ब्रैकेट आई प्लस जे, टी अंडर ब्रैकेट आई प्लस जे यूनिट वेक्टर, राइट, एज टी गोज फ्रॉम 0 to 1। सो डी आर इक्वल टू क्या होगा, डी टी अंडर ब्रैकेट आई प्लस जे, समझ में आया। फॉर द सेकंड कर्व को क्या करें, पैरामीटराइज कर दें, पैरामीटराइज कर दो भाई सेकंड कर्व के लिए, तो सेकंड कर्व के लिए पैरामीटराइज कर दें, yes, are you getting?
yes, sir, I didn't understand.
Eh?
Didn't understand.
No. For second curve, where it goes, C2 is a straight line from origin to 1, 1.
Yes, sir.
1, 1 means from origin to 1.
Y,
Let
y
this
is
be.
equal to x.
Yeah, this is x 0, 0. And here that is 1, comma 1. So 1, comma 1, this point and this point, you have to go this and then after this, right? Like this.
Yes, sir.
So that is 1i plus 1j. So how we are considering here along this line? So that is y equal to x line. Na? So that is ti plus tj. At any point here on this curve, how will we go for ti plus tj curve?
Yes, sir. Yes.
So that we say r, we can write ti plus tj, and dr, that is, you can say for that dr what we have to go for? This one, dr by dt into dt, like this, right? So one differential is 1, so that is t directly we are using here. So means I to I, so that is t, and j to j, once again t, so tt 2t, and here then we get 2t dt is equal to 1. Are you getting? Or may I write this? How this 2t comes?
Yes, sir. Right.
You understood that? So starting and ending points of the curve, two lines are equal. Isn't equal? अभी इसकी वैल्यू देखो क्या आ रही है? इसकी वैल्यू देखो क्या आई? 2t का इंटीग्रल क्या होता होगा? t स्क्वायर बाई 2, 2 कैंसिल, अपर लिमिट लोअर लिमिट, दैट इज 1. तो देखो ऊपर वाले कर्व का भी आंसर 1 आया, नीचे वाले कर्व का भी आंसर 1 आया, देखा?
Yes, sir.
तो ये हुआ, समझा? अरे भाई जो वर्क डन नहीं निकालते हैं, वर्क डन डजंट डिपेंड्स ऑन पाथ, ये बताता है. तो आप इस पाथ से जाओ, चाहे C2 कर्व से जाओ, f डॉट dr ही तो होता है वो वर्क डन वाला, वही वाला रिजल्ट सही है
Yes,
सर.
sir. Yes, sir.
तो वर्क डन बिकॉज द फोर्स विल बी कंजर्वेटिव. अगर ऐसा होता है तो फोर्स कंजर्वेटिव होते हैं, राइट? यही सब चीजें हैं. अब चले, ऐसे प्रॉब्लम्स बहुत सारे बनते हैं, प्रॉब्लम तो बाद में मैं देता हूँ. इसके आगे यही है, वर्क एनर्जी थ्योरम यही से डिजाइन होता है. वर्क एनर्जी थ्योरम बोलिए तो मैं एक्सप्लेन कर दूँ. वर्क एनर्जी थ्योरम भी यहाँ से डिजाइन होती है, ठीक है? वर्क एनर्जी थ्योरम आप निकाल लेंगे, मैं इस पर क्वेश्चन दे दूंगा, आप एक क्वेश्चन करें, फिर मैं चार्जिंग लगाता हूँ. एक क्वेश्चन मैं छोटा सा दे देता हूँ. क्वेश्चन नंबर 1, पूरा अभी तक जितना पढ़ाए हैं, ठीक है, उस पर क्वेश्चन है. तो अभी हम लोग एक अर्क लेंथ वाली बात पढ़े हैं, ठीक है? द अर्क लेंथ of parabola y equal to x square, or x lies between 0 to 1. It's 0 to 1, right? The integral, the arc length of the parabola is given by ऑप्शन दिया हुआ. ऑप्शन दे क्या?
Yes, sir.
ये ऑप्शन इज 0 to 1, या आया हुआ है सिलेबस के एग्जाम वाले एग्जाम में. 1 plus 2x dx, ये वो नहीं लिया गया, ये ऐसे 1 plus 2x है. अगला ऑप्शन में 2 की जगह पे 4 है, और फिर 2x स्क्वायर है और 4x स्क्वायर है. 4 ऑप्शन दिए हुए. लेट मी सी दिस, ट्राई करें. ये चल ही नहीं रहा। हाँ इसमें लगाओ ना, इसका चार्जर लगाओ, चल ही नहीं रहा। बी ये पेन ही नहीं घूम रहा है, तो इसमें नहीं 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 ये चलना चाहिए। ऐसे इधर से लगाओ ना, इधर से इधर से इधर से। हाँ इसको नहीं निकालना, ये नेट चल जाएगा। जल्दी लगाओ, टूट जाएगा। 4%। हाँ बोलिए क्या हुआ?
सर 1 + 4x का अंडर रूट।
अच्छा आंसर इंटीग्रल ऑफ अंडर रूट
1 + 4x का
ऑप्शन तो है अंडर रूट 1 + 4x का। यस अंडर रूट 1 + 4x स्क्वायर करेक्ट, सही आंसर। ऐसे भी लगा दो, ये लिख ही नहीं रहा। अच्छा नेक्स्ट क्वेश्चन लेंगे, सही है। 0 to 1 अंडर रूट 1 + 4x स्क्वायर, सही है। नेक्स्ट क्वेश्चन नोट करें, मैं बोल रहा हूँ अभी लिख देता हूँ। द लाइन इंटीग्रल ऑफ द वेक्टर फील्ड u इक्वल टू -i, u वेक्टर जो दिया हुआ है वो है आपका -yi यूनिट वेक्टर और +xj यूनिट वेक्टर, +x × j यूनिट, ये u दिया हुआ है, ठीक है। काउंटर क्लॉकवाइज अराउंड अ ट्राइंगल विद वर्टिसेस 0 0 l 0 एंड 0 l इज इक्वल टू, निकालना है हुआ ये। क्वेश्चन समझ में?
what were the vertices again, sir? 0, 0,
0 0 l 0 एंड 0 l।
Okay, sir.
आ गया कौन बोलो पहले आया था। यस अच्छा मैं इसको लिख देता हूँ, पहले ये क्वेश्चन लिख देता हूँ ताकि आप क्वेश्चन करते रहें। सेकंड क्वेश्चन वाज क्या था, लाइन इंटीग्रल, ठीक है। इसका भी मैं ऑप्शन कंप्लीट कर देता हूँ और बोलेंगे तो सॉल्व भी करूँगा। द लाइन इंटीग्रल, सही, द लाइन इंटीग्रल of the vector field right, of vector field u is equal to this counterclockwise वो सब clockwise ही रहते हैं, इंटीग्रेशन clockwise around a triangle, around a triangle with vertices with vertices 0 0 right, and l 0 and then after 0 l right is equal to question mark। ए ऑप्शन दिया हुआ है, ऑप्शन देते हैं बी सी डी ऑप्शन। ये ऑप्शन है 0 और इसका है हाफ ऑफ एल स्क्वायर और यहाँ पे है एल स्क्वायर और यहाँ पे है 2l स्क्वायर राइट। इसका ऑप्शन है बी ऑप्शन क्या था, ये बी और ये वाला सी ऑप्शन हो गया राइट, सी ऑप्शन हो गया और ये डी ऑप्शन हो गया। दैट वाज 0 to 1, ये आपका सही था आंसर, अंडर रूट 1 प्लस ये नहीं सही था 2x square dx और 0 to 1 integral of under root 1 plus 4x square dx and here that is 0 to 1 that is under root 1 plus 4x dx. Is it okay? This was the correct answer. D option correct. तो चले हम लोग देखेंगे correct क्या कौन सा option है. तो फिलहाल इसका शायद D option correct आपने बता दिया फुल. एक और क्वेश्चन लेना चाहेंगे. पहले ये कर लो. हाँ बताइए. ये तो अर्क लेंथ वाले पे जो क्वेश्चन था वो है. इसको एक्सप्लेन करें कि फर्स्ट वाला. कैन आई एक्सप्लेन फर्स्ट वन और आर यू गेटिंग?
Yes, I understood.
You understood, no? ds is equal to, we have to write, ds is equal to, you have to write under root dx square and plus dy square, right? And here it is simply dy, you can say dy by dx, you can say this as under root, how you have done, under root 1 plus, you can say over here, dy by ds, what I told initially, dx and that is dx, and here when you recall this, then dy by dx whole square, dy by dx that is 2x, so that is under root means you can see over here that is under root, yeah, that it will be called 1 plus for dy by dx that we say differentiating, that is 2x whole square and that is dx, right? And that was from 0 to 1 according to as per condition is given, so that's why D option is correct for x square. Yes, correct. What about second problem? Second problem, as you see over here, that is from 0 0 L 0. How you are taking trying to do this? So as u vector is minus yi plus xj counterclockwise around the right angle, around the right angle, around the which triangle? I haven't written here. Around the right triangle. Okay. Let's see. Around a triangle with vertices 0 0 and 0. So it is not. Okay, fine. Triangle will be right triangle. Of course. Correct. Due to this vertices, you can see over here, because 0 0 L 0, you see when you are going to just draw the vertices like this way. Let me draw the vertices over here. One of them is 0 0 L 0 and that we say 0 0 L 0. You can recall here as this, you see 0 0 L 0 and that is L comma L. So of course that it will be the vertices, isn't it? And we are going from 0 0 to L 0 and then after we go for L comma L in counterclockwise like this, right? So how we are getting, this is the right angle triangle undoubtedly. So around the right angle triangle, if you are integrating this all, then what do you have to find? Integration over circle, curve, counterclockwise, and that is u dot dr, right? As u is the vector quantity over here according to this field. This field is minus yi plus that you say xj. So how to tackle this? As this curve is around this triangle, so we can recall this curve as c1 u dot dr, right? And then after plus from c1 to curve to c2, this line c1, c2 and then c3. So there are the three segments u dot dr and another curve that is c3, that is u dot dr. Hope so you're getting. C1 is this, C2 is this, C3 is this. So what about C1? Let's say, yeah, please. C1 के लिए हम लोग कहाँ जा रहे हैं? 0 0 से L0 पे जा रहे हैं.
Yes,
तो for this, what we say for dr कर्व के लिए इसको मैं डिटेल एक्सप्लेन करूँ कि मैं डायरेक्टली दूँ. 0 0 से L0 जा रहे हैं. तो what we on C1 From 0, 0 to L0. So dr we can write dxi. Only on x-axis we are going. So
Yes, sir.
for dr, what do you have to say? You have to say for dr that is dxi. Is this all right?
Yes, sir.
dxi, dxi unit vector, and for this C1 curve. But here, what is the u vector was there? Something I plus something j. So what you will write over here?
Minus y
Yeah.
dx.
So for this very, you have to say C1 curve dxi is there, no? I unit vector. So dxi is there. So minus y, u is the means whatever the vector field is, u is minus I and j. So along this, when we go for 0, 0 to L0, so what is y? As let me actually this will become 0. How? Let me explain this separately or directly I can explain here. Look here, 0, 0 to L0, as you will get here only y because I is present over here. When you make with I component, then I component is minus y, right?
Yes,
So,
sir.
but minus y is from 0, 0 to L0. So, y is y coordinate. Let's see y coordinate 0 and 0. So, the result will be
0.
0. So, this is the reason here. So, directly I am writing this as 0. Hope so you are getting. This
Yes, sir.
dr will become this one, and this is y dx, and y will be from 0, 0, as you know, 0, 0 to you are going for L0. So we are coming from this 0 to this 0. And so the result will be 0 finally. So what the answer will be? Here 0. What about this for other curve? Second one,
Will be
from
dy
L0 to LL.
delta.
You know L0 to LL.
Yes, sir.
L0 to LL. Then you have to parameterize for second one. For second one, suppose let's say second one we go for u dot dr. So for curve second, as on C2, on C2, on C2 curve, we are going from L0 to where? LL, correct? LL, particularly. So if you are parameterize that curve, then what is R? R equal to what we say here? That is,
d I
let's
J.
say, means you can say over here that is L minus S, whatever the position is, L minus Si, and here then after plus Sj, whatever the position of S is, means S is going from 0 to L. S goes from 0 to L. 0 to L you can see over here, right? So what do you say about this one? So 0 to L, so that dr will become dr. If you differentiate this dr, then what will get? Minus ds into I, and here plus ds into j unit vector, right? So this is, so therefore on this line segment, if you make u dot dr, right? U dot dr, because u dot dr is required na, for C2 curve. So if you say u dot dr, then it will be x plus y, x plus y ds, correct? Look at point here. That is u was minus y and x. So that it will be negative negative plus. So that is y ds, and for this x plus y ds. And here when you get x plus y ds, and that is x plus y will become, that is x and y coordinate. When you add this x and y coordinate, then x and y coordinate, x coordinate is L and y coordinate is L, that is x plus y dx from 0 to this point on curve C2, that is LDS. LDS directly we can say. So finally the curve C2 is LDS. So you are getting, so that what we say, combinedly we get LDS in this curve in C2. So for LDS, what we say here? L 0 to L, 0 to L. So L take out common, ds under one integral is S, so the answer will be L square. Hope so you are getting. Are you getting this one?
Yes, I got it.
So okay, fine. So once you get similarly go for C3 curve. So for C3 curve, if I see u dot ds, u dot this one dr, u dot dr, what you will get? U dot dr for C3 curve. For C3 curve. For C3 curve, if you see for u dot dr, then what we will get over here? So directly can't you go for C3 curve? For C3 curve, 0 comma L to 0 comma 0. 0 comma L, no? What was that?
0, 0.
Yeah. 0
Comma
comma
L to
0
L
L comma L to 0 comma 0. L comma L to 0 comma 0. So finally, what we have, we find dr in if we go for dr component. So dr will be what is that? Dyj. Is this okay? Dr, that is dxi plus dyj. So if you make here I and j component, so that is a pretty dyj. Is it okay? Why so? Because अरे भाई L comma L to L comma 0 comma 0. So x becomes 0 now. X becomes 0. So
Yes.
dr will become dy into j. So only the difference is there. So in that situation, once you have to go for C1, C2 and then C3 also. Achha, C3 yes. So summing all this contribution, what we get here? So C4 you will also get 0. C3. C3 you will also get 0. So integral of circle C u dot dr, what you will get? Only that was L square. Second one only is contributing. Second one it is only contributing L square. Achha, what is was the area of this triangle? If you see what is the area of this triangle, half of altitude into base. So L into L length, so half of L square. But
Yes.
the answer is L square. So which is twice the area of triangle. Which is, you say, which is twice the area of triangle. Twice the area of triangle. Right? Which is twice the area of triangle. Are you getting?
Yes, sir.
So the answer is L square. No? Option is the L square. Yes. L square option. One more question we can provide here if you see. Let's do one more question along the same route line. Question number 3. Objective type same question on the same pattern line integral. A mass m is shot upward from the ground, right? Suppose question made like this one. A mass small m is shot upward. Is shot upward from the ground with the speed u naught. From the ground with speed u naught, right? Acha. Attains a maximum height. Simple motion under gravity attains a maximum height. Attains a maximum height, right? And then falls back to ground, and then falls back to ground, back to ground, right? Calculate the work done by gravity on the mass. Calculate the work done by the gravity on the mass. Yes. अच्छा, options. A option is 0. B option is V naught square upon 4G. C option is V naught square upon 2G. And D option is V naught square upon G. Yes. Try to do this. Are you getting question?
Yes, sir.
First, you have to check this one that a mass have is shot upward from the ground with speed u naught. Okay. So, as you have to find the work done. So, for work done, that is force and displacement. W is equal to f dot dx, dr, whatever that is. So, force is a vector quantity. So, define the x-axis to point vertically upward. Suppose for somehow you can say y-axis also, according to as per your choice. That doesn't matter. So means along means line integral we are going. So you just consider as x-axis upward. You can assume anywhere. So if you are going to assume x-axis as upward, right? X-axis is upward, right? So what is force? Force on this ball. Force on
Mass
this
into
ball will be
acceleration.
minus mg into unit
Yes.
vector I, because I vector is there and gravity is acting downward. So minus
Yes.
mgi. Is this correct? Everybody?
Yes, sir.
This one is F. Okay. This force is F. And the work done by the gravity on the way up is minus mg x max,
G into X.
whatever there is, x max, right? So work done by gravity on the way down will be, this is on the way
We
up,
say
this is on the way up, and for the way down will be,
positive mg
yes,
into
plus
X.
mg x max, whatever there is, at the same
Yes,
height, right? So finally, the maximum height attained by the mass, x max is the maximum height attained by the mass. So what is the
Yes.
total work done? So total work done is,
0.
yeah, total work done is 0. 0 is the correct option. It's okay. Everybody?
Yes, sir.
Fine. So the same route line, we can go some no problem over there. And okay, fine. So let's see over here. So surface integral of a scalar field we have to go for, and then for vector field. So we have some time. Let's start surface integral, right? So dividing surface integral of scalar field, right? Surface integral of scalar field. Let's go for surface integral of scalar field. Okay, so let's see. Let any scalar field defined as f is equal to f of r. Okay, so what is the surface field? That is f of r, and here we say ds. Ds be the surface area, right? So if you parameterization of the surface as which is given as, so let me make a parameterization. So you say a parameterization of the surface S is given by r of u comma v. Let's say u comma v be any means parameters which varies. So x as u comma v and into I unit vector you can say, and plus y as u comma v into j unit vector, because surface area this one dr, that will be the vector quantity. So plus z, that is u comma v, and that is k unit vector, correct? So where the position vector r points to the surface. So if you see over here, then what do you say about ds? So ds will be, you can go ahead like this one. ds will be that you say, let me make this, its magnitude of del r by del u into del r by del v, right? Mod. So means अच्छा ये निकल क्या रहा है, ये ds जो आपकी एरिया है, एरिया डिफाइंड बाय दिस वन, ये दो वेक्टर्स हैं, टेंजेंट वेक्टर्स हो गए dr by de और dr by dv टू द सरफेस, ठीक है? तो इन लोगों का जो क्रॉस प्रोडक्ट है ना, वही निकाला। एरिया क्या होती है? एरिया इज अ वेक्टर क्वांटिटी l क्रॉस b, तो उनके जो टेंजेंशियल वेक्टर्स हैं उन दोनों के जो क्रॉस प्रोडक्ट है u और v पे डिपेंड कर रहा है, तो dr by du और dr by dv इन दोनों का क्रॉस प्रोडक्ट, तो ये ले रहे हैं हम लोग, तो दैट्स व्हाई इसको ऐसे लिखेंगे पैरामीटर फॉर्म में, into du into dv, du और dv ये बहुत नहीं है, तो मीनिंग गलत जाएगा, बस सिंपल du और dv, राइट? लाइक दिस। अच्छा, अब if r is equal to, if r वेक्टर तो रहेगा, बस r लिखो, वेक्टर ही है, r of x y, सपोज अगर ये लिख रहे हैं तो क्या होगा, x I यूनिट वेक्टर प्लस y j यूनिट वेक्टर एंड प्लस z which depends on x and y, that is, let's say, k unit vector, right? So that what we recall here, that is so if the surface lies over xy plane, means if the surface lies over xy plane, and can be described by that is z equal to z of x comma y, here, then we can use this x and y as our parameters, right? So what do you say here, r of x comma y, let's say this is, that is you can recall that's the same thing, that is this one, but I written here, no need to write again. So that is, you can say, better just you can recall this point over here, this, and here you can see this one, right? Spread by z. So let's say this. Here this is r. Clear? So therefore, what we consider here, therefore, we can say that is del r by del x, del r by del x is equal to that we say I. Unit vector x differential is 1 and plus that is del means del z by x. This function is here, so that we say del z by del x, because here that will be the constant, differential is 0. So del z by del x, z depends on x, so that we can write either k unit vector, or you can say if we are differentiating del r by del y, then you have to go for j unit vector, and plus del z by del y into k unit vector, because z is a function which depends on x and y both. So that's why I'm writing like this. And the cross product is given by, how to find cross product of these two vectors. So the cross product of, because why we are using cross product, because here we have to go for this one, del r by del u and del r by del v cross product for ds vector, right? So for ds vector we have to go for cross product, so that we say let me write here cross product, or cross product, what we say, del r by del x, okay, cross del r by del y, which is required in the previous I have shown here. Let's see once again, del r by del x and del y means that was the function of u and v, and here the function was x and y. So that's why del r by del x and del r by del y, right, is equal to, how to make a cross product, by using determinant, you know, the formula of a cross b, that is I, j,
Yes, sir.
k, and here you have to put these all the coefficients of I, j, k. So the coefficient of I is here, that is 1, the coefficient of j is 0, and the coefficient of k is, that is del z by del x, correct? And what about this one, del r by del y, as here, that is j coefficient is 1, I coefficient was 0, no I coefficient, k coefficient was, that is we said del z by del y. So if you solve this determinant with respect to first row, you say n, where you just solve this. So better so how to tackle this, better just write, how to write I into this 0 minus this. So with the help of this I into unit vector into, you have to delete this first row, first column, 0 into this
Yes.
minus del z by del x.
And with that
So
del
what do you
z,
have to say, minus del z by let me write del x I, right, and minus then we go for j, plus minus j, you have to say minus j, delete this and this minus this.
del z
So
by
yeah,
del.
exactly. So finally what do we say here, j, this minus 0, this will be 0, only del z by del y will be there. So
Yes.
that is negative of you say del z by del y
Del
into
y,
j unit vector, correct? And plus undoubtedly that is k1 minus 0. So that is plus
del
k
z.
unit vector is there, and hence in this way you get these two terms, and so the surface integral in this case will become, let me write here the surface integral in this case uh, becomes what we find here, integral of that surface integral fr, that was ds, and that was a double integral, you know, for surface area, and that is a, let's say, and that is f of r, that is x comma y, as r is a function of x comma y, and here what we say here, under root of, are you ready, under root of 1 plus, what is this, is the means any vector ai plus bj plus ck, you say under root of this square plus this square plus this square. That's what I'm doing over here. So for 1, and here that is del z by del x, and that was what do you say, a whole square, and plus del z by that what we say del y whole square, right? And but just to get this one also. So and then we can write here simply, that is dx, and here for this dx and dy. Let's once again please check here ds, that was what was ds over here. So ds was del r by del u and del r by del u du dv, and similarly here that is dx dy in this case here. So hope so you are getting this one, how to find surface integral. Is it okay? So let's we take some question to just understand how just we will use this whole formula, isn't it? So what do you have to do with this one? You have to find, uh, let's see, two questions you have to do. One we can find here, that is that we can say find the surface area. You have to find surface area is surface integral. So for surface integral, as you see here, we can use this as you can go for cylinder, cone, else any. So let's take a question, one question, so that we can understand this. Okay. So I'm feeling bored. Let's take one more question. It's okay. So that we can understand surface integral very easily with the help of this question. And I will give two more questions for homework. First, I will put some question over here. Compute the lateral surface, the lateral surface, lateral surface area, lateral surface area, A is equal to integral S, that is ds of cylinder, cylinder. Cylinder, cylinder, ठीक? Cylinder. You have to do in two ways, in two different assigned ways. In two, actually we can do two ways. So I'm giving two assigned ways in two ways. As what ways was? First way, what do you have to show? Unroll the cylinder. Unroll the cylinder. Unroll the cylinder and compute area of resulting rectangle, of resulting, ये एकदम बच्चों वाली बात, रिजल्टिंग रेक्टेंगल जैसे करते थे क्लास 6-7 में समझाया जाता था 9-10 में बच्चों को रेक्टेंगल, राइट. और सेकंड थिंग जो है आपको वो इंटीग्रेशन वाला यूज करना है, तो दैट इज डिफाइन द सिलेंडर define the cylinder parametrically, मतलब cylinder parametrically as r equal to a, ये formula cos theta into I plus a sin theta. ये समझ रहे हैं क्या है? ये तो सिलेंडर का सर्किल का हो गया, और प्लस z के जब ले लेंगे तो दैट विल बिकम सिलेंडर, राइट. फॉर z लाइज बिटवीन b to 0, अभी बनाते हैं सिलेंडर, एंड थीटा, एंड थीटा इज लेस और इक्वल टू 2 pi and greater or equal to that is 0. Okay, so and compute the surface area integral, and compute the surface integral, compute the surface integral. अच्छा देखो, यहाँ सिलेंडर बनाना है, ठीक है, तो पहले सिलेंडर तो कहीं ले लो, सिलेंडर कहाँ मिलेगा, सिलेंडर ले लो, नहीं, रेडी वेयर हाउस में, चलिए मैं अगला देखता हूँ सिलेंडर कहाँ मिलेगा, तो सिलेंडर दिखेगा, तो मैं ऐसे करता हूँ कि यहाँ पे ये ले ही लेता हूँ, सिलेंडर एक बना देते हैं वही वही। तो ये मैं क्या कर रहा हूँ, एक सिलेंडर बनाना पड़ेगा हम लोग को, एक सिलेंडर बनाना पड़ेगा, इसको बनेगा, ऐसे बनेगा, ऐसे बनेगा, राइट, और बस एक चीज़ बन जाएगा सिलेंडर, राइट, ये नहीं किया, एक सिलेंडर बना देता हूँ, ये ऐसे खड़ा कर दिया, इसको ओके, बस लाइक दिस, तो ये राइट सिलेंडर तैयार हो गया। एक सिलेंडर बन चुका है, अब यहाँ पे हम लोग को एक्स वाई जेड एक्सिस बना लेना है, एक्स वाई जेड एक्सिस, तो ये देखो क्या होगा, यहाँ से ये ले लेते हैं, ये एक्स एक्सिस, और ये वाला अपना हो गया वाई एक्सिस, और ये वाला हो गया अपना जेड एक्सिस, राइट, ये जेड एक्सिस, ओके, सो ये जेड एक्सिस ये हो गई अपनी वाई एक्सिस हो गई, राइट, और ये हो गई अपनी एक्स एक्सिस, इसको भी ऐसे, ओके, चलो देखो ये अभी एक्स एक्सिस वाई एक्सिस जेड एक्सिस बन गए, राइट, तो ये इसको लिख लेते हैं एक्स एक्सिस है, and this what we say here, that is y axis, and this what we call, that is z axis, right, तो इसकी जो रेडियस है x की वैल्यू क्या, z की वैल्यू 0 से b तक लाई कर रही है ना, तो z की वैल्यू ये जो लेंथ है वो दैट इज b, ये लेंथ, राइट, एंड दिस इज a will be radius of this base, because we have considered a cos theta a sin theta over here, right, r की वैल्यू ये दिया हुआ है, तो यही दिया हुआ है क्वेश्चन में। चलो ट्राई करो, इसका लैटरल सरफेस एरिया निकालो। हाउ टू टैकल दिस, अब बताओ भाई, चलिए सॉल्व करिए। फिर ऐसे ही कोन के लिए भी हम लोग करेंगे क्वेश्चन, ठीक है। तो कोन का क्वेश्चन मैं दे दूंगा आपको बाद में। तो पहले अनरोल करके सिलेंडर करना वाला समझे क्वेश्चन, फर्स्ट वाला तो हो गया होगा। फर्स्ट वाला तो क्लास 6-7 में बताया गया है, अरे 9th-10th में। अनरोल द सिलेंडर एंड कंप्यूट द एरिया ऑफ द रिजल्टिंग रेक्टेंगल।
यस सर।
इसको भाई यहाँ से कट करेंगे और ये रेक्टेंगल बन जाएगा, तो यू विल गेट दिस रेक्टेंगल। तो ये आपको पहले सबसे पहला मेथड तो और बहुत इजी है। ये जो है आपको क्या करना है कि यू हैव टू अनरोल दिस सिलेंडर, ये अनरोल कर देना है, कुछ करना ही नहीं। ये अनरोल कर दिया हम लोगों ने, अभी सिलेंडर को अनरोल कर दिया, तो क्या मिल जाएगा, सिलेंडर को अनरोल करेंगे, so that it will be, you will get here this as the length b and this will be the length 2 pi a, ये वाली जो length है, ये वाली length, this one, ठीक है। तो that is simply the lateral surface area will become nothing 2 pi ab। अब यही आंसर आना चाहिए, ये तो क्लियर, ये तो, लेकिन ये तो ऐसे बता दिया गया। अब यहाँ पैरामीट्रिकली जब डिफाइन किया गया सिलेंडर को, ये फर्स्ट मेथड हो गया। ये सेकंड वाला भी मेथड क्या बताया जाएगा, सेकंड मेथड से जो बनाना है। तो डिफाइन सिलेंड्रिकल पैरामीट्रिकली क्या है, तो आर वॉज डिफाइंड विद ए कॉस थीटा इंटू आई यूनिट वेक्टर प्लस, एक मैं करके दिखाता हूँ, ए साइन थीटा इंटू जे यूनिट वेक्टर एंड प्लस जेड के, राइट, वेयर फॉर जेड लाइज बिटवीन 0 to b, तो दैट इज 0 to b एंड थीटा लाइज बिटवीन 2 pi and 0। ये इट इज गिवन इन द क्वेश्चन, ऑल्दो यहाँ पे इक्वल टू नहीं रहेगा, ये स्ट्रिक्ट इक्वलिटी रहे तो ज़्यादा बढ़िया, क्योंकि एक बार 0 ही पकड़ेंगे और फिर 2 pi 2 बार तो पकड़ेंगे नहीं। तो टू फाइंड द इनफिनिटेसिमल सरफेस एलिमेंट, so what do you say here to find this surface element, let's see, to find the infinitesimal surface element, how to find the surface element, partial derivatives of r can be written as del r by del theta, differentiate this, that we say minus a cos theta, differential is sin theta, minus a sin theta, minus a sin theta, isn't it? Minus a sin theta, minus a sin theta, okay, and plus a cos theta, by cos sin theta differential is cos theta into j unit vector, अच्छा यहाँ पे I रहेगा, that is I, correct, and what about this one zk, that is of course undoubtedly that is 0 over here. So that is what do you say about this one, del r by del z, that is, that we say a, are you getting? So the cross product is del r by del theta and del theta by del g, that we have to say the, so the cross product is del r by del theta into cross product of del r by del z, you have to find. That's the same analogy. Just go ahead, using that determinant, find. You just please calculate I, J, K, correct? Same. What do you say here? Are you getting?
Yes, sir. Yes.
A cos theta, yeah. And what about this one? 0, 0, 0, and that is 1. Correct? Solve this. I, this 0, A cos theta. So that is A cos theta into I. And what about this one? J, that is this, and minus A sin theta. So that we say minus j position was also there. So plus a sine theta into j. Are you getting how this comes plus?
Yes, sir.
Let me write down here. Yes, a cos theta and where that sine theta. No, sure. Where that sine theta is on. Let me write once again. Here that is a cos theta, a cos theta into I, and that was minus a sine theta, minus a sine theta, minus a sine theta, and that is j. Correct? Is this okay? So this j was negative. That it will
So it should be
you
plus
check this plus minus j and
minus j and
minus a j sine theta.
plus.
Yeah, plus a sine theta. Fine. It's okay. Anyhow, that is let it be, and so that we can say that del r by del theta, del r by del theta. We have to take another page. Cross del r by del z, del r by del z, right? Mod that what we call. Are you getting what I'm writing over here? We have to take this mod that is under root of mod of any vector.
Square. Well,
Yeah,
yes, sir.
that is
A square
a
cos
square cos square theta and plus
plus
a square sine
sine.
square theta. I am writing s and c for sine and cos respectively.
Yes.
That is say that is called a. So simply that is nothing. It is a. And
Yes,
here,
sir.
so what we say this much. And what was the surface inch area? You know the surface area. Uh, surface area is given by area is given by a is equal to integral of that is s and here that is ds, right? So if you see here, then we have to make a double integral that is 0 to b as is along with z, and for that theta the integration limit was 0 to that is integral theta is up to 0 to 2 pi was the theta limit was 0 to 2 pi. Look here, that was z was 0 to b and theta limit was 0 to 2 pi. So that we have to go for a this one is a and d theta into dz. Are you getting? So what do you say about here? When you now one by one integrate, you will get 2 pi a and 1 that is b. So that is 2 pi 2 pi. What do you write? AB.
AB.
Correct. And that was the surface area. Isn't it? Similarly, you can go for some another problem also by making a cone like this one. If we make here cone also and the lateral surface area, you can go ahead like this doing these types of problems in the same manner. Eh? So you do this so in homework. This one, cone and else. Okay.
Yes, sir.
Uh, along this with line integral. So let's do some another problem. Means along with cylinder, you can compute the lateral surface area of cone also, right? So for cone, if I let me give the problem at least, right? Right. So you see here that I'm giving the problem at least, right? You can do over later on. see that I will attach this problem also later on. So question number 2, you can go this problem and try yourself. Compute as like cylinder. So compute the lateral surface area capital A, that is integral of S ds of a cone. So for cone you can make like this way. Here also you can go like this by making unrolling the cone and then you make like this. So I'm doing like this. You can see that this is the cone here. So let's say this is the cone and make this line. Yes. So the cone is here and there is another lateral side. Try this properly. Correct. Fine. So this is the cone here, and you see that you have to make a z-axis also. So you just make a z-axis. Say this is z-axis. So this is z-axis here, and then we make this as z-axis. Let me make the cone. This z-axis here, and let's say this is as y-axis. This here, so this is y-axis. Okay, let's say this is here, so that is x-axis also. Okay, so it must be y-axis, this has x-axis, and this what we call z-axis. Okay, so let's see over here. Okay, fine. And so this length will be here. You know, there is somehow you will see that this length is see this length will be here A, and you can see this as that is smaller. No, that is B. No, B length. B is given over here. Okay. So this length will be given as B length, and this length will be given as A length. This length, correct? So this is B height, and this is A, according to this. And what do you have to do? You have to do this in two different manners. Um, let's say, yeah. So first A, that is, you have to unroll the cone, right, and compute the area of resulting circular sector, and compute the resulting area of circular sector. That was how this was. Okay. So what you have to do? That is well, means you have to do this one. Like this. Yeah. Yeah. Let me put like this. Okay. Fine. Now look here. So for this cone, first you have to do this. Unroll the cone. Unroll the cone and compute the area. And compute the area of the resulting cone sector. And compute the area of resulting circular sector. Circular sector. Okay. And B portion, that is you have to find. You have to find this. That define cone parametrically. Define cone parametrically. Don't worry, I will give the parametric equations also parametrically as that is R equal to AZ upon B cos theta. This is the cone, equation of cone, that is plus AZ by B sine theta, right? And that is unit vector J plus ZK unit vector, correct? And here this is for, that is Z lies between B and 0. Z lies between B and 0. And, that is theta lies between 2 pi and 0. 2 pi and 0. Is this alright? And compute the surface integral. And compute the surface integral. Compute the surface integral. Yes, you tried yourself. Surface integral. So you all know that what the final area of the cone. Then we will go for surface area of the sphere later on, the next lecture. So here what you have to do, you have to make the circular sector. So what is the lateral surface? So I will do any one of the method for this cone. So if you cut the cone from here anyway, just like cylinder you cut, and you expand this, then in two-dimensional situation, you will find the sector, right? So what type of sectors you will get? So you see here, then what sector you get here? You get like this way. Oh, this way. Let me take this sample. Let me expand this later on. We'll divide. Fifth part. Right. And we'll take one of the sector. Take one of the sector here. Rest of the sector we'll leave. So once we take this sector here, this is the sector, right? So this is the sector over here, you see. And here this sector will become, you see that this is the sector after cutting the cone. After cutting the cone, you will get this type of sector, right? So what the result will be here? under root of, that is, yes, what will be this length? 2 pi a, and this will be under root a square plus b square. Look here. This length is a and this length is b. Pythagoras theorem, this length you can find.
Yes,
This
sir.
length
Yes, sir.
under root of a square plus b square. This blue length is a, this length is a, this length is b. So this length is under root a square plus b square, right?
Yes, sir.
So that's what I'm writing over there. That is under root of a square plus b square. Okay. So let me write down under root a square plus b square. This one. Okay. So the lateral surface area of the sector of the circle of radius under root a square plus b square. So the lateral, lateral surface area of sector of circle of radius radius under root a square plus b square. What is the formula of area of sector? That is the area of sector you can find over here. That is A is equal to, that is arc length of sector, arc length of sector upon area, circumference of circle, circumference of circle. Here there is no need to learn this formula. This is pretty easy. I can tell you another thing also. Don't worry, let me write first. Area of circle. Here I am using this formula as like unitary method. So area of the circle, if you consider entire length of the circle means circumference of the circle, that is 2 pi r, then its area will be pi r square. So what about the arc length of sector? So if the arc length of the sector is something, then what is the area of this sector? So that is the area of that shape. So this is the area. So finally, we substitute these values over here. You will get the area of this sector. That is 2 pi a. That is the area of arc length of this sector. As you can see here, this length is 2 pi a. Right? This length is 2 pi a. Are you getting this 2 pi a? How? Circumference of the base of the circle, and the circumference of the entire circle, that is 2 pi. That what I am saying over this here, from where the circle comes. If you complete this sector, right? From this the circle, I have divided this. So that is 2 pi. Radius was under root of a square plus b square. Okay, and that is what we say here. Area of circle was pi, radius is square. So pi into that we say a square plus b square. It is clear. So when you solve this, then what do you find here? Then this 2 pi related, and that is pi a under root of this 2 pi related, and this pi left over here, pi a under root a square plus b square, and that's your area. So you can take out common over here also. Pi ab you can take out common, and what we get this result, 1 plus b square by a square. No. I have taken b common, so a square by b square, isn't it? A square by b square. I took b common here, so a square by b square, right? So this is the formula, and a by b, that is a by b, a square plus b square. If you see here, you can take out b common, so pi r l, that is the formula. So that is the sector of the formula, and when you go for the integration using this equation, right, you will get the same result. You try yourself in the homework, isn't it? Are you able to do this? You have to find dr by d theta and dr by dz, as in cylinder we have done. That the same thing you have to do over here. In the cylinder, what I have done now, the same thing you have to do over here for cone.
Same formula also.
Which one? What are you saying?
Like same formula, parametric.
Parametric, I have given this in cylinder.
Yes, sir.
I have given this, in cone. In cone it is given r equal to az by b cos theta, az by b sin theta j. Is it clear? So from here, what do you have to find? You have to find del r by del theta. Del r by del theta you have to find from this. And then from this only you have to find del r by del z. Then you have to make a cross product as previously we have done over here. Del r by del z and del r by del theta. Look here. Del r by del z and del r by del theta you have to find for this cone and make a cross product, and this same work if you will do this you will get the entire the cone this one surface area also, and you will get this same result. It's okay. So
Yes,
can't
sir.
you do this? It's easy. You do your homework. And if you won't get, yeah, I will give the idea also here. I don't want to bother about that. And one more thing I want to give over here. One more questions so that you can go like this way. That sometimes it's paraboloid is also there. So compute the lateral surface area of the paraboloid. On next turn I will give, or I will write the question and I will send in this PDF. You have to find this paraboloid is also there, like this one. Let me show you what is paraboloid. Paraboloid like this way. This one is means like this, like this. Paraboloid is also there. It's okay. Means this is like a cone type, and like this, and this is z-axis. Let's say this is z-axis. Okay, and let's say this is x and y-axis is here. So let's say this is x-axis, and that's what we call y-axis. This is, you say, z-axis here, and let's say this. Let this once again. This is b, and this is a. Instead of cone, that is it is paraboloid, and paraboloid. This one equation of its parametric form is also given over there. So that is a square z, and that is b under bracket x square plus y square. Although if this such type of questions will come in the exam, then they will give this result as in the parametric form. Z is less or equal to b. Although these all are standard format, it's okay. In mathematics we learn this all. That is compute the resulting two-dimensional integrals using polar coordinate. Right. I will write this question and I will give you. Do try yourself. Uh, okay. So I'll give some PDF also just to go through the homework question for surface. Next one we'll discuss surface integral of vector field. Right. Surface integral of vector field, and we'll do some more questions, numericals on this all segments. So as we have learned here, surface integral of surface integrals although, but we are will call scalar one. Right. And next onward we will go for surface integral, and then we go for fundamental theorems. That was Green says, Stokes and this. And next one we'll go ahead. Okay. So I am
Yes, sir.
winding up here. Time is too much. It's okay.
Yes, sir.
Okay. So we'll consider this as two lectures. So I'll send the PDF of this immediately.